Good morning, guys. Welcome to today's lesson, April 16th review. You can see our aim today. How do we find missing angles in circles? So we're just going to take a look at a bunch of review questions. You can pause the video at any point, work on them by yourself or with the video. Totally up to you, but we'll work on 4 together now, and then 3 I'll leave for you to complete throughout the day. Remember, your Delta Math is also due tonight at 8 o'clock, so make sure you get that done as well. All right, number 1 says find x and explain your answer, but for right now we're just going to find x, which you can see is an exterior angle. Now that exterior angle is made from 2 tangents, so really the minor arc here is 140, and the major arc is the rest of the entire circle here. As you follow it around, that's the rest of the circle. So remember, we have 360 degrees in total for a circle, so what's left there for that major arc? It would be 220 degrees, right? 220 and 140 makes 360. That's the entire circle. So whenever it's an exterior angle made from 2 tangents, the minor arc and the major arc make up the entire circle. Alright, so to find the exterior angle, major arc, the bigger arc, minus the minor arc, which is the smaller arc, and you divide that by 2. We get 80 divided by 2, which is equal to 40 degrees. Number 2. In the accompanying diagram, AB is a diameter, you know that's going to be very important, of circle O, and chord CD intersects diameter AB at E. If the measure of arc AD is 100, so right here we have AD as 100 degrees, and the measure of arc AC is equal to 40, find the measure of angle DEB, DEB, right here. So now we don't have an exterior angle. What type of angle is that? That's just an angle made from chords that intersect, or a chord and a diameter that intersect. So the rule for that, remember, we have an angle really across from that that's the exact same angle. Those angles are equal to each other because they're vertical. Vertical angles congruent. So what are our 2 angles that we want to focus on? What are the 2 intercepted arcs? It would be this 40-degree angle here, and now the other side would be this arc here, arc DB, which we don't have. So those 2 blue arcs are the intercepted arcs. We need both of those. Remember the rule, we add those 2 together and divide by 2. It's really the average of those 2 arcs. So now how do we find that arc? Alright, so you have to think about how can we use that given info that they said AB is a diameter. It's very important here. So as you follow around AB from here, we have 100 degrees, and if you continue that, that will make up half of the circle now, which is 180 degrees. So what's left here for arc DB would be 80 degrees. Alright, so to find x, an angle formed by intersecting chords, add those 2 intercepted arcs, the 40 on one side, the 80 on the other side, and divide that by 2. So this would be 120 divided by 2, which is equal to 60 degrees. Number 3, remember at any point you can try these on your own. If you don't want to watch the video, you can just work on the problems and then check the answer key later. In circle A, the measure of arc BD up here is equal to 56 degrees. And BC is a diameter, another key piece of info with a diameter. Remember, that's half the circle, 180 degrees. Find the listed measure and explain your answer. So we got to find 5 angles here. All right, let's see what they ask us for first. The measure of angle BDC, which is right here. So we got to be thinking, what type of angle is that? It's an angle that's formed on the circle, right? An angle that's formed on the circle. It's an inscribed angle, so it's equal to half the intercepted arc. See, as this opens up, that angle right there, right there. So if you, that's just opening up the angle, all right, so that it's essentially touching an arc. It opens up and it hits an arc, so you can find the intercepted arc. So your intercepted arc would be all the way here from blue to blue, and that's half the circle. That's us just using what they told us about the fact that BC is a diameter. All right, so that's 180 degrees. So this angle here, angle BDC, is 90 degrees because it's equal to half of the intercepted arc. The intercepted arc is 180, divide that by 2, you do indeed get 90. So let's fill that in as a right angle. Now in your notes you'll find that as an inscribed angle in a semicircle. So it's an inscribed angle, which means it's on the circle, and its intercepted arc is, it's essentially a semicircle. It's half of the circle, so you're thinking 180 degrees. Alright? So angle BCD now. Angle BCD, let's locate that. BCD, which is right here. Alright, I'm going to erase these highlighter marks so we can now follow this angle. So see, once again, that's an inscribed angle. It's on the, it meets the vertex is on the circle. Watch as that opens up. So it's a here and here. So as you can see, that opens up so that the intercepted arc is 56 degrees, the one that they gave us. So you divide that by 2, inscribed angle, cut it in half. And we get 28 degrees. Alright. Another angle, angle DBC. Right here. That's, once again, it's an inscribed angle. It meets on the circle. Let's watch as it opens up. Hits here. And there. So your intercepted arc is this yellow arc here. Now we don't have that arc, but could we find it? Once again, this amount from B all the way around to C, that makes up half of the circle. That's the other half of the circle, so that's that other 180 degrees. So 56 and something will make 180 degrees. You have to find out what that something is. So 180 minus that 56, and you find out that your intercepted arc is 124 degrees. So take that 124, cut it in half, and you get 62. Alrighty, another one. Angle BFG. Right there. So same procedure, another inscribed angle. This question's all about practicing inscribed angles. Find the arc that it intercepts and divide it by 2. So watch as that opens up. That X there opens up and also hits that 56 degree arc. So 56 divided by 2 again, so we'll get 28. And the measure of arc BC we already found. We had to use that for letter A there to find angle BDC. Arc BC is half of the circle, so 180 degrees. So like I said, a lot of practice with inscribed angles. Remember that rule. What type of angle is that? It's an angle that essentially meets on the circle. Find the intercepted arc and cut it in half. Alright, one more we'll do together, and then you'll try the next 3 on your own. You'll check back for the answer key later, see how you did. So number 4 here in the diagram, and it's number 26 on a region, so 2-point extended response question. In the diagram below of circle O with diameter BC, okay, once again important to see diameter half the circle, and radius OA, chord DC is parallel to chord BA. Now we haven't seen this at all. We haven't talked about parallel in terms of chords or anything really with a circle, but let's mark it. It's important info. They told you it for a reason. DC and BA, those arcs there, are parallel. So what's the day one parallel rule, guys? What do we think about when we see lines or segments that are parallel? Alternate interior angles. So they tell us, let's keep filling in here, they tell us that angle BCD is equal to 30 degrees. So BCD, follow that, 30 degrees. Determine and state the measure of angle AOB, which is here. Alright, so they told us parallel, you're going to use it, so let's try to make some alternate interior angles out of these parallel chords. You can make that Z as follows. So you could find that this angle here, ABO, is also 30 degrees. Now there's a million different ways to go with this question. This is just one of the ways, so if you're seeing it a different way, that's absolutely fine. Alright, but this 30-degree angle we could use. It's an inscribed angle. Watch as that 30-degree angle opens up and hits this arc here for CA. So the arc is equal to double the inscribed angle. Like before we were finding the angle, so we're cutting it in half. Now we're gonna use this arc to help us out. Finding the arc, you have to double it. So this would be 60 degrees. And now the fact that, remember they said diameter BC, so this 60 degrees and something, as we follow around for half of the circle, remember that makes 180 degrees in total. So what's left for arc BA to complete half the circle would be 120 degrees. Why is that helpful? Because the angle we're looking for, angle AOB, watch as that opens up here and here. That's the intercepted arc, that 120 degrees. Now this is a central angle. That's a first day of Module 5. So as that angle opens up, it's equal to the intercepted arc. So angle AOB, the one they're asking us for, a central angle, is equal to that 120 degree arc. So no divide by 2 or anything like that. 120 degrees and you're good to go. Alright, so try these problems on your own. You got an exterior angle, a couple exterior angles, and then this question has to do with the segments that are formed by intersecting chords. So if you're not sure about this one, check your notes from the intersecting chords day where we talk about segments. Your Delta Math is due tonight. Make sure you take care of that. Have a wonderful rest of your day, and I'll see you mañana.